Hi guys, so today we have AtCoder beginner contest which has just started. Let's go to problems. Where are the problems? Oh, I have to refresh? Okay. So open all problems. This is the faster way of doing some things. So problem A, your first judge, given a string S, print a C if it perfectly matches hello world, otherwise print no. Okay. So I'm gonna have my template ready, so I'll have to type it. But other than that, not much to say about this problem. So we have string S, we read string S, we check if it perfectly matches this phrase, then we print AC. Otherwise we print wrong answer. Okay, let's just submit. I don't think that there is much to this problem. Yeah, we got accepted. Let's quickly add some important strings to our template and keep going. So problem B, log to n. Given a positive integer n, find the maximum integer k such that 2 to the power k is at most n. Okay, n can be long. So all we do is just read n. And because 2 times maximum value of n does not overflow longs, we can just loop over all powers. We can also call a library function, but it's not necessary. So we have like k, and let's call p is the power of k. We'll take like k starts from 0, power starts from 1. Power should be at most n. K gets increased, power gets multiplied by 1, which we can by 2, which we can represent as a binary shift. Let's actually add this is here, and this goes here. So now this needs to not to be long, and this needs to be long. So we exited the loop, so power is strictly greater than n, which means that we output k minus 1, because k already does not work. This time I'm not so sure that we did everything right, so let's compile. I guess half of this is not really necessary, but we'll type the compile comment fully just in case we need it later. Return something like 6 gives 2, 1 gives 0, that's one number gives 59. Okay, let's submit. Not much going on in these first problems, obviously. They just ask you to translate something from English to programming language of your choice. Problem C, one more A, B, that's fun. I remember we've seen this problem recently, like 2 or 3 weeks ago, something like that. Want to find the k-slex graphically smallest string among the strings that are a permutation of string S. Well, okay, but like I mean, because how small is S, we can just loop over all permutations, right? we read S, we read K. Well, X graphically smallest, so first we need to sort string S. So it starts from the first one. We also index K is 1 based, so we have to address that as well. And I just call next permutation of as begin as end, I believe. Just print S. Not sure how it behaves when there are equal elements, but well, we can always test it quite easily. So okay, so far so good. Okay, this one is the last one, right? Okay, I'm not sure what this problem was all about, but apparently, like, maybe not all languages have next permutation function, but I'm pretty certain that Python has like iterator_permutations, which just do what they wanted us to. Okay, so got accepted here. Not much to comment about. To comment on, I guess, is correct preposition. So problem D, Coprime 2, we're given a sequence of n positive integers a. Find every integer k between 1 and m inclusive that satisfy the following condition: GCD of ai equals k for every integer I such that I is at most n. Okay, so we want to count numbers k which are coprime to all elements of a given sequence. So basically that is like generally in number theory problems here. It's quite often the case that you don't care about powers of primes, and what you actually care about are just primes. And this is the case here as well, I guess. Because what we are going to do is we're going to quickly factor every AI. Which we can do because AIs are up to 10 to the 5th, we can just factor in square root. So let's see. Should I do that, or should I think I should do that. So like get of size m plus 1 will denote whether some value is good or not. The way we are going to solve the problem is we want to find all prime divisors of AI, because k is coprime with all AIs if and only if it is coprime with all their prime divisors. So what we do is the following: we loop over all numbers d, the potential divisors, up to square root of AI. If they are actual divisors, then what we say is, okay, so like d is not good, and we also divide AI by d, which I believe should actually happen like, well, I mean, I can do as well just this. Because like having an if and nested while loop is just a little bit ugly. So in any way, I believe we have to check if AI is greater than 1, then good at AI gets false as well. So now we marked all prime divisors as bad numbers. We should probably also mark like good of 0 as false, so that at the end, like after we do something, we will be able to output, I guess, accumulate, but I'm not sure. Okay. Well, let's just write a normal for loop. So like, we want to count k's. Originally, we don't have any of them. We say like, okay, from k equal to 1, k all the way up to m inclusive. If got at k, then we just increment the counter, and the end we output the counter. What happens here is that we want our usual sieve loops to propagate information from primes to everything else. So the way it works is we go from d to equal to 2, d times d is at most m, increment d. Oh, that's a bit unfortunate that m is called m. Let's say max. Nope, not like that, but like that. Because now we want to say is if d is bad, in fact, if d is a bad number, then we have to propagate that information to all numbers that are divisible by d. The way we do it is we say like for all multipliers of d starting from d squared, because it does not exceed the max, we say that we increase m by d. We can start from d squared because this way every number will get labeled by its smallest prime divisor that is not coprime with some of the AIs. So what we do is we say good at d equal to false. Just normal, very standard numbers theory. You don't need those like smarter optimizations. Just understand how sieve works. Oh, wait a second. Okay, we need to print numbers. Okay, that's not a big deal. We just say like, okay, vector in vector in C. We'll say C gets pushed back to K. We print C size, and for CI in C, we print CI. Was this bad? So I did not read the statement properly, but apparently they also want us to like interesting. Why this didn't get labeled? Fascinating. Okay, several things can be improved. Oh, it's, oh, okay, not nice. Okay, so we are getting like extra good numbers that should not really be good. For example, we are getting 4 for some reason. Despite that 6 has a prime divisor of 2, so 2 is labeled as bad, but then 4 is not for some reason. Oh, okay, stop stupid typos. Oh, that won't help. I have to recompile, of course. Okay. Yeah. Oh, one per line. Okay. I mean, white space usually doesn't matter that much, but will be nice. Let's submit this one already. Wasted some time here, but hopefully not too much. Wait a second, how is that runtime error? Oh my goodness, AI can be greater than M. Okay, AI can be greater than M. Right. If D is less than or equal to MX, that's very unfortunate, but that's entirely my fault. So we access good where? Here, like here the access is completely justified, but here it's not. So hopefully now it should work, right? Because like what else can go wrong? Like obviously we had a mistake when going out of the bounds. Hopefully we are not doing that anymore. Good is of size mx plus 1, therefore we check that it's less than or equal to. Yeah, okay, let's submit this one. Still a mistake, of course, but like... What? Oh really, I mean what? Okay, so 22.7. The previous one was 13. Oh, 10. Oh, why I did not read this properly? That was not great. Like, why do you show me only runtime error when I also have wrong answer? Like, if I've seen it like here, then I would maybe think for a little bit longer. Unfortunate. But okay, we had 10 wrong answers. Now we only have 7 of them, so probably some of those wrong answers were caused by some of these values not being like out of bounds, but valid numbers, just garbage numbers. Is it still possible that we have some sort of error here with like undefined behavior? Yes, maybe, but like shouldn't really matter that much. I mean, ascending order, I definitely satisfy this because I just loop here in ascending order. Oh, we do something wrong with size. Well, that's impossible. so frustrating. I really don't know what to do. Like, it's just, I've done it so many times, it just has to work no matter what. How are the people doing? Like, they should be doing alright here, right? Like, this is completely normal problem, right? Yeah, everybody can solve it. Okay. So we're clearly doing something wrong. So you're wondering, overflow should not be a problem because all the values are up to 10 to the 5th. We only loop up to square root of numbers here and here. So I completely don't understand what's going on. Like, that should work, I don't know. This is of course very professional debugging process by me, but still, like, okay, we just have to read our code carefully. We have n, we have maximum that we want to check. We read them, we read our array, have a Boolean array of size that fits all numbers from 1 to mx inclusive. Originally, every number in this range is good. Loop over all numbers, we loop over all potential divisors up to square root of ai. While the divisor actual while the potential divisor is a divisor of ai, we divide ai and label the corresponding entry in the good table as false. We then check if ai still has any prime divisors, namely if it is a prime, because if it has 2 prime divisors at this point, then both of them are at least d, and therefore d squared is less than or equal to ai. So here ai can only be a prime number between 1 and mx inclusive. We label the corresponding entry of the table with false. And loop over all divisors. They are not good. Then we propagate those bad values forwards. Say that this is not good as well. Then we just loop over all possible values. That is not necessary, but like whatever. No, I honestly don't understand what can be wrong here. Like that should not help. That should not help. I don't know. That's like a bad practice to resubmit your solution when you have not found an error. But what else do we do here? Like that should not help, right? Like nothing can overflow. That vector bool is not very important, that new line character is also not very important, so. I don't know, I feel bad about it already. We're clearly doing something wrong. It is subtle enough for me not to be able to find it. Yeah, unbelievable, like. Okay, so all we did is we wasted one submission. No, but I don't, okay. Maybe I don't understand the, wait, the solution is correct, right? It's like, if this GCD is not equal to 1, meaning that k is bad, then it happens because they have some common prime divisor. We should be able to detect it by looping over prime divisors. So the solution is also correct. Like, I don't really know what's going on here. Perhaps it's better to just ignore that problem for now, because I have no idea what we did wrong. Like, we clearly did something wrong, but I don't know what it is. And this problem is extremely complicated to debug when you only have one sample, and like, okay, like maybe I should just check some of like obvious tests, but I don't know what are the obvious tests for this problem. Yeah, let's say we have 5 numbers and we check up to 100. Let's say that I want to exclude 6. Something like 5 times, let's say 5 times 13. Let's say that I want also to exclude 7 and 11. 100, because just why not, and then like 81. So I actually excluded 2, 3, 5, 7, 11, 13. That's why we don't see many values here. So just see the primes. Okay, no, I have completely no idea what went wrong there. We should just... should just ignore that for now. Okay. Because we are lagging behind so badly in this contest, we can also try to maybe gain some information from the standings. In case, let's say, E is also not nice. Okay, so E appears to be, okay. E appears to be solvable. AtCoder in another world holds 10 types of contests called AAC through AGC. It is not immediately clear that the middle, like J, stands letter of the alphabet. Excuse me, but like it could have been better if you specified this formula. There will be n contests from now on. The types of these n contests are given to you as string s. The ith character of s is x, the axc. Okay. AtCoder. AtCoder will choose and participate in one or more contests from the n so that the following condition is satisfied. In the sequence of contests he will participate, and the contests of the same type are consecutive. Okay. Formally, when AtCoder participates in the next contest and the ith of them is type di, then for every triple of integers ijk such that they are. Yeah, okay. That's a confusing way to word it, but it's okay. One number of contests AtCoder can choose to participate in modulo that. N is up to 1000, okay. Well, like, okay. One obvious idea is to loop our all bit masks of like letters that we have not used yet. Also, like have DP on bit masks and prefix lengths. Okay, I'm lazy. You know me, I'm lazy. Longest, do I have to output? No, I have to count. Okay. P00 is equal to 1. So like the second parameter is mask of contest that we already used. Or perhaps we also want to add the current contest to it. That is still fine. That's still fine. No, it's in 10. Okay, those params are like prefix lengths, mask of used letters, last used letter. What we do is we loop our like, okay, from that to that. Most that's. So we want to know if we can add SI to something like this. So we'll loop our like last also. We have to check if first we have to check if what's wrong here? What is wrong here? Yeah, let's just ignore that for now. So first we need to check that last is actually included in the mask. Then we also yes, if it's not, then DP here is 0. We can even specify that explicitly if you want me to. Class is equal to 0. If this bit, however, is set, then there are two cases. If SI is equal to SI minus A is equal to last, and else DP at I plus 1 mask last can get DP at I mask and last. Otherwise, so like we just can't use the current contest to change anything, so you just copy that value. Otherwise, we can append this to last, because this character like matches last. We can append it. There are actually two transitions, so like DP at I plus 1 mask last. Suppose that it was already turned on, right? So we just append. This is impossible. Append to current group. This is just skip. There is also one scenario when we start a new group, which happens as follows. So okay, this one, add mask and last. Oh, that is getting bad, but we may try to loop or like what was the previous character. And then we say that dp at I+1 mask last plus equals dp at I mask where last is turned off and then which ends at previous. This value has to get modded, obviously. There's one more scenario. Start a new sequence, which is a bit different. So dp at mask I gets 1. This is only possible if mask is equal to last. If mask is equal to this, probably like this. This is a little bit sketchy. That works in 10 to the 8th time. Should be not that bad, hopefully. We also need to like combine the answers somehow. What I guess we can do is we loop our all values of mask. Okay, like increase mask, we loop our all values of last. Answer gets incremented by dp and mask last. And answer gets modded. We add answer. Hopefully that works as intended. To be honest, I have no idea. I'm still thinking in the background about the previous problem because how ridiculous that is. What's wrong here? Missing something. What the heck am I missing? What is wrong with you? This is a pair to that. This is a pair to that. What the heck are you missing? So confusing. They say that last is undeclared. How is that possible? Oh my goodness, that's 4. I don't know what's wrong with me today. Okay. 11. Why did we get 11? Well, let's see how bad that is. It's quite bad. Okay. Don't understand anything. Oh, wait a second. But can we skip if it's in the current group? I think we can. Like this should not be else, this should be instead this. Yeah, I'm pretty sure that we can skip if we are in the current group, right? Even if it like, even if it's fine to add, we don't have to add, right? Come on. Okay. Okay. Let's see if this 10 to the 8th solution is fast enough. No, not that. Can so annoying. Okay. It's actually reasonably fast. We'll get back to D after I read F. Because we done quite badly in this contest. Yeah, but it appears that F is completely doable. Let's see. Dist Max, actually, what is the number? Okay, like, okay. So given n distant points in a two-dimensional plane, point I has coordinates xi, yi. Let us define distance between points as minimum, or okay. Find the maximum distance between two different points. Yeah, let's imagine okay, that is just easy, right? I mean, log squared may be a little bit too ambitious. Like 20 times 20. 4 million, 80 millions. No, that should be fine. That should be just fine. Yeah, no, but that is just like very standard tricks, geometry tricks. Let's get ourselves a struct point. I probably want that. Probably want also. 0, 0 is fine, right? So the idea will be to first binary search over the answer, because that is just like not a hard part of the solution. Let's say, what is the maximum possible? 1 billion, right? So let's say we go with that. So we go with that. However, binary search, okay. Like this answer is never possible, meaning that we know that we have to output log, because log is always possible. So while harmonious low is at least 1, middle gets low plus harmonious low over 2. And because of this value is only 1 billion, we can as well do that. rate high. It's usually not important. So we'll have like if can middle, if middle is possible, then low gets middle, otherwise high gets middle. Now we have to define function can. Our predicate to binary search on. That's a function with signature alike. What we also need to do is sort points I guess by, let's say, by x coordinates. Let's also make the predicate complete, I guess, the order complete. Why we need this? Because our idea is like, let's say we want to check if it's possible to have the answer be at least, so let's say 1 million. What we do is we create a sliding window of length 2 million. For each point, like the point is a center of the window. No point within this window can be paired to that point because they have small x distance. So what we now have to do is have to look outside of this window and then pick apparently maximum and minimum y coordinates and just check if they work. So we'll need prefix minimums and maximums for like. Okay, I can do that. I can do that. Prefix maximums, suffix. Okay. Prefix minimums, prefix maximums, suffix maximums, suffix minimums. Size is n+1, let's say, for each one of them. Maximums should be initialized with something like -1. Also, I call this inf. So n+1 inf. Suffix maximums should be initialized with -1. Suffix minimums with inf, right? Just standard. Right, then we'll look for I first in this order to fill prefixes. So I guess it's better if I break it like this. Prefix maximum at I+1 gets a maximum of prefix maximum at I, and then points at IY. Minimum. This loop goes in reverse order from here. Let's say that it goes like this, actually. Negative, negative, then suffix, 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 suffix. That is technically speaking incorrect. Okay. Now I remember why I usually write it the other way. No, this should be correct. Like this is from 0 to n-1. This is from 0 to n-1. It's from 1 to n. So just to be correct. What this function does is will take a sliding window of size of width 2 times middle. The easiest way to do this with like extra lock overhead, which still should be fine, is as follows. So we just look over all possible points, then we say like, okay, left is this minus middle, right is this plus middle, or rather this, because we like sort on X. However, we should actually call lower bounds in the vector of points for this value. With this function, which will return that px is less than x. This way we are able to find the first value that is well, this way we find first index in P such that pi at x, first index j in P such that pj at x is greater than that. Yes. No, I need to check std lower bounds. I don't remember which way the partition is, like if it's we are interested in second version, right? Ordered before second, so this returns true if point is ordered before the value that we're looking for. Alright, appears to be correct. Now this is of course an iterator, so we have to call that. And I feel like we may need to subtract 1 from it, because actually this is like the element that we're looking for, but we can do it a bit later. More or less the same thing happens here, except for nothing. Okay. Like this, you can get rid of this if you actually like explicitly move L and R. But I think that extra lock overhead here does not kill you. I would really doubt it. So what we want to check is that either prefix maximum at L minus let's say pi x, pi y. We are interested in y coordinates now. Is at least middle, or pi y minus prefix minimum at L is at least middle, or suffix maximum at R minus pi at y is at least middle, or pi y minus suffix minimum at right is at least middle. Surprisingly, indices appear to be not off by 1, but just right. Here we can return true, here we can return false. Okay, not really sure about that, but let's see and check. Result of the expression is not used. That is very good catch. I got used to Python lambda functions recently. Oh no, rather to what is the conversion? Where is the conversion? Line 30. What? Who is long here? Oh, distance is long. Okay, to be honest, I don't care about that. That does not guarantee us anything as usual in geometry. It can very well be wrong, but let's try, because I'm a little bit lazy to make sure the indices are correct before we actually learn that they are not. This solution is not 100%. I'm not 100% confident in this solution. Oh, okay, yeah, you can see like you don't die from an extra log factor, so like just this is simpler than to code in slide window, then you're welcome to use it. Not doing great, to be honest. Yeah, you can see that some people are already finished, and like G and H are much harder than other problems. We are doing quite bad, yes. Okay. No, honestly, we are doing quite bad. Yeah, it appears to me that we should look at D one more time before looking at G or H. Whoa, okay, so this problem is complicated, I guess. Or rather not complicated, but like it can be tricky. Maybe I'm not reading the constraints carefully enough. Coprime to every number, right? Coprime to every number. So if they are not coprime to one single number, then they are bad already. I'm trying hard to figure out what's wrong. Oof. This is just so simple, what can go wrong? All numbers that are not coprime with at least one element of a sequence have to be factored, right? We only care about prime divisors, that for sure. Okay, let's say we only have one number and m is equal to like, I don't know, 30, but we ban this number. And it perfectly bans 2, 3, 5, 7, as it should. Oh, I'm an idiot. I am an idiot. So bad. So bad. Like if, oh no, like, okay, like, that is just insane. No, but that's obviously my fault, but still, it's very, very not great. Yeah. What? Oh, that is, oh. Okay, I'm just very stupid, apparently. These are not your normal sieve loops. These are loops of the form, of the same form, but they are different. Right? Okay, that's just very bad of me. Yeah, I guess we can also submit this and it will be faster. Because overflow was never an issue in this problem. Like what happens is that I said several times that we loop from d squared because every number will get labeled by its smallest divisor, but actually it should get labeled by its smallest bad divisor, which has not necessarily been processed yet. So it is just so dumb of me. Okay. Okay. So like 2D is bad if D is bad, but we don't label if we have not labeled it before if 2 was not bad. So it's just me being very dumb here. Don't mind me. Okay. See if we can maybe do something about G here, but that does not sound likely. Because previous time, if I remember it right, which I missed for some reason, probably because I was just a little bit too late. Previous time, like first 6 problems were easy to some extent, and then these 2 problems were extremely difficult. So like for this one, probability of me solving it is like 70%. For this one, it's 4%. So very unbalanced problem set, as opposed to this one, which was like actually, okay, like 5, 10, 40, also a big jump here, but that's okay. That is like, it's always this way. And here's like 1 harness. This one was not very balanced. Let's see if this one is balanced. And we can do it by Northern Ukrainian filter. Right. So H appears to be extremely hard, but then G appears to be not that much harder than F, right? F was solved by 300 people and G was solved by like 100 people, so potentially solvable. Let's take a look at it. We have 30 minutes to be fair. Let's take a look at it in the, not in all problems, but in the specific problem. Time limit is increased, interesting. So that we can see the timer. For some reason, timer is not shown on tasks for print page. I guess because it's not supposed to be on the printed page. So yeah. We have n candies arranged in a row from left to right. Each candy has one of the following 10 to the 9 colors, 1 through 10 to the 9, not surprisingly. For each I from 1 to n, ice candy from the left has color Ci. Takahashi will choose K from... Okay, so that's like combinatorics, okay. We stand the chance here from n candies to get those K candies. There are binomial coefficient n choose K, ways to choose K from the n candies. Takahashi will randomly select one of these with equal probability. Because Takahashi wants to eat colorful candies, the more variety of colors his candies have, the happier he will be. For each scenario, find the expected value of the number of different colors Takahashi candies will have. You can prove that the sought value is a rational number, of course, as in all combinatorics. Print the model. Yeah, we know the drill. Okay, we clearly need to use linearity of expectation in some form. This appears to ban like quadratic solutions, but not ban some other tricks. Okay. Obviously, we don't care about specific colors, so I guess in order to map from int to int will be a frequency table for it. That's not important, okay. I'm not sure if this is like necessary, but it may be helpful. Well, because in the... Yeah, it may be helpful, okay. You have to do that for each K. For each K, we have to find the answer. Fascinating. For K equal 1 and for K equal n, the answer is very clear. For every else scenario, what is the expected number of candies? 5-star because we actually get a penalty. Okay, so like, oh. That is not, okay, that is not independent, but that's still fine, right? So what I'm trying to think about is the following. So like, why do we get a not K colors out of K candies? Because some colors coincide, right? What the probability that two colors will coincide? This is problematic because the probability that two given candies will coincide, that's very easy, right? You just know that overall you have a binomial coefficient of n out of like 2 out of n, and choose 2. And coincide, they only coincide when you choose like if you have V candies of some color, like here, then you have V choose n, and then sum of such for overall V divided by n choose 2. That's the probability that two candies will coincide. It does not exactly help because like number of different colors is not directly connected to number of pairs that coincide. So maybe that is not the best choice of method to solve. Maybe what we should think instead is like, what's the probability that each color will be represented here? Because the number of different colors is the sum of indicator functions of each color being present. So we should just check in how many scenarios each color is present. And then, oh, very nice, very nice, very nice. Okay, so this is essential. Okay, yeah, I figured out the solution that works in O of n, square root of n. The square root comes from very non-trivial reason, which I will explain once I get this annoying sum out of the way. Right, much better. And also we will need binomial coefficients, so and choose k. What's the maximum value? This value is maximum and this value is maximum. And is actually possible, so and choose k of I0 gets and choose k of I gets 1. Then, oh no, it's still going, but at least it's not that obvious. So here we go from 2 actually we are up to n inclusive. Go for g from 1 to I not inclusive, and choose k from I choose j gets anxious k from I minus 1 j minus 1 plus anxious k from I minus 1 j. This value gets modded. Yes. No, just this. Then for this frequency array A, we will actually need to build another frequency array, which leads to that square root factor, because there can't be more than square root different frequencies in a frequency array. That is just a very nice trick that last time I used in CodeChef February challenge, something like that. 2021, of course, because I don't remember anything that was happening in 2020. So I loop over all values in frequency array so that map at AI gets increased. Why do we need this? Because now we loop for all values of k from 1 to n, and we will compute our answer as follows. So here, we loop our key value pairs in our map. Answer gets increased by value multiplied by something. The answer should get modded. Perhaps that value should also get modded, or we can do that. Now what is this value? So like V corresponds to, like, we have V colors which appear k times. Now what's the probability that color that appears k times? Oh, actually that's yeah, we have V colors that appear m times, okay, m times. What's the probability that we get a color that appears m times if we take, we choose k values out of n? Well, it's not hard to see that the probability is 1 minus what? N choose k from n minus m choose k divided by n choose k from n to k. That's like overall what we have. Now these are like bad values, so we have to subtract that probability from 1. Now of course we can't do just that, because that's it is not how modular arithmetic works. We actually are supposed to do, first we are supposed to do that. Second, we are supposed to take modular inverse of that body. That body over here. Oh, wait a second, we can't compute binomial coefficients. Whoa. Whoa, take it easy. Okay, that problem is solvable. That problem is solvable, that's for sure. Well, we don't need too many binomial coefficients. And actually the solution will work in of n, square root of n log n time, which is considered a bad meta, but you gotta do what you gotta do. Say base exponent, result while exponent if exponent is odd. And return gets multiplied by b, return gets modded, base always gets multiplied by base, always gets modded, the exponent gets shifted to the right one, so like we, in order to beat, we do that. Okay, now we have base here, we don't have exponent modular inverse. We return modular power of b mod minus 2. It's quite common. Plus equals c. Okay, we have modular inverse. What we don't have is NCK, because NCK takes quadratic memory, which is clearly unusable. What we're supposed to do on the contrary is, like here, we already know all values of v for each v, all values of m for each we may want to query that. So instead, what should be computed is like NCK is not a vector of vectors. This part is of course still useful. This we can't afford. Want that? So NCK will be an ordered map from int to vector of ints. Because if we need n minus m, that we need all k within it, so great. Now here what we do is we do the following. For int k from nck at n minus m resize n plus 1 nck n minus m 0 gets 1. For k from 1 all the way up to n, nck n minus m k gets nck n minus m k minus 1. Then we have to multiply you by k. So this one body should be actually long. Very suspicious if it will pass, but let's try. So this gets multiplied by k or divided by k. Let's also say for convenience that MP at 0 gets 0. This way we'll process n minus 0 here, but it won't affect answer here in any way. Okay, I just need to write down the expression carefully. So what is that? That is this factorial divided by this factorial times e minus a minus k factorial. The previous body is k minus 1 factorial, but here k plus 1 factorial. So what happens? We should divide by modular inverse of k, which we can cache if we need to, but it appears to me that this loop and this loop complexity is the same either way, so that is a constant factor optimization, which we may need, but let's not try it straight away because time limit is increased once again. modular inverse of k, because that's like a new factor that appears here. But also, if we like get rid of this, and we think like, okay, what is the last number that did not get removed? Like these numbers remove this number, they cancel out. But the first number that did not get removed, well, it appears to me that this is this. So that is like this times this minus this times this. This number nck n minus mk should get multiplied by this number. Okay, it should get modded here and here. Potentially in this order. To be fair, I don't know what this is doing here, if I'm honest. Oh yes, okay, now I see. Okay, no, that is correct. Well, it's probably best to initialize it like that, right? Okay. No way it's gonna work, but we want to change return somewhere, somehow. Why? Oh, here no, here I don't care. 58 modular inverse gets converted to int. Argument conversion from type I to oh, this is formally long, but this it takes like not long argument, but hey, this is always modded, so no problem here. And here I guess no, we need to fill till the end. Okay. So it appears that it has worked. Let's try another example. 17253767893574870. The reason why I only check first numbers is because here the answer is multiplicative, so if you are just a little bit wrong, you will be off by a lot. If answer is additive, then it makes sense to check the last numbers instead, digits. Oh no! But the thing I care more about is whether it gets a TLE or not. Okay, certain things that we can obviously change is change that to that, but I'm not sure how much it helps. I'm also not sure if this is TLE or not. Looks like it is, because like it takes a lot of time to work on each of the samples. Or rather not samples, but like tests, I guess. Oof. But this is like correct. Let's take a look at the details. With TLE just a little bit, so maybe caching modular inverses will help. This modular inverse needs not be performed every time. This modular inverse also needs not to be performed every time. Oh, so actually I was incorrect when I said that we have an extra log factor. Or we do. No, we do. No, we don't. Okay, but no, we don't, but that's tricky. Oof. Yeah, exactly. Let's move E. And we already can replace that, so it becomes faster. Now here it's tricky, like we need to replace binomial coefficient. Binomial coefficient gets computed from those simple values. So what is the way to replace binomial coefficient is, okay, this means it can be like pre-computed once, like here. Here NCK, we should actually also have minv NCK, with the idea that we access it here. Minv NCK will work as follows. So originally it's still 0, but then it starts with the same value, but this should be turned around. So like, instead of multiplying by inverse of that, we'll multiply by inverse of that, and instead take this. Also, let's say that we'll loop up to at most n minus m. Doesn't really have to make sense to have k larger than n minus m. So this way, n minus m minus k, this can be 0, but this is at least 1, which is necessary for us to be able to take modular inverse. So yeah, not exactly sure what went wrong here. Perhaps I copied one extra. Let's see how much it helps. Declared, of course, yes. This should be computed here. Understandable concern. From our compiler friend. So that appears to be correct. That also appears to be correct. Oh, we can submit from here. I never knew about it. Okay. Let's go ahead and try this feature. Okay, no, so it's still a wrong answer. I wonder why. Also uses a lot of memory, but I believe that we have a lot of memory. We have 1 gigabyte of memory. This one TLE, this one does not TLE, uses twice as much memory, but gets a lot of wrong answers. Why does this happen? Oh, is it because this is negative? Oh my goodness. Yeah, of course this can be negative. Like, what were you thinking about? So dumb. Oh, we can submit from here. That will be faster. Yeah, just do this all the way, right? Right. Okay, great. Well, not great because like kinda we won't be too high up in the standings. But we'll be in an okay position. Yeah, as you can see, problem H is quite hard. Yeah, so like actually we should I know this guy? Oh wow, that's a lot. That's a lot. Okay, interesting. Very interesting contest. Fortunately, I don't have power of will remaining to read H and think about it, but that's like that was interesting. So just a quick reminder, like a review of what we did. Problem A, simple implementation. You need to know only how strings work. Problem B, simple implementation or a library function. You could call log base2, it will log2, it will compute it for you. But yeah, overall, like, well, we want to find the largest number such that power is at most k. You could also loop over all numbers, and instead of like keeping track of power explicitly, just call pav of 2 and k, or even just be smarter and call power of k as such, or rather as such. So that is the same as p in this context. So p actually is necessary. So we can just prove the point. We can submit it as follows. Let's go ahead and submit for problem B. Yeah, it got accepted. Okay. So you want to find, you just need to know how the powers, how to compute the powers. Here you need to know how to compute next permutation. It's present in C++, Python as well, itertools.permutations. I don't know about Java, but obviously it should be there somewhere. You just have to find it. And you have to understand that like you need to believe in yourself and understand that you don't have too many permutations. In problem D, a little bit knowledge of number series required, but looking at the standings, people do know number series, they do know about prime numbers, they do know that GCD is 1 only if it's coprime, so like you have to be coprime with all numbers. So you need to want to ban all prime divisors. You can see like 3,000 people solved it, so no, it's not hard. It's not hard. You know, I like this one better. You kind of need to understand how C works. I wonder if you could do something more stupid here, but I don't know. Yeah, you have to be careful, just be careful, because I'm so used to writing C from D squared and from up to square root that I haven't even saw it, that it may be important in this problem. So, but sometimes you can switch to another problem when you don't know what's happening. In problem E we had simple DP with bit masking. It's not simple, let's be real, it's not simple. Only 1,000 people could figure it out of like more than 8,000 participants. So not that simple. Maybe I overcomplicated this as well because I just bashed a lot of parameters in and it worked. Maybe you can have fewer parameters, but overall the code is not long. The cases correspond to like normalish stuff. So in case you know about bit masking, that problem, and DP, that problem should not be difficult. It would be difficult if you had to get rid of one of the params, like let's say incorporate last in mask somehow or something like that, then it's difficult. Or incorporate previous, like get rid of last or previous somehow. Not sure how that is possible, but probably that is. But when you can just bash a lot of for loops in, for loops, great. N 2 to the power of 10 to the 8, you're still fine with C++. I guess it's kind of hard with Python, which is why my friend Josh had problems with this question. Regardless, like this is just DP. You bash a lot of parameters in, you get your answer. Likely for us, they allowed this. Also nice trick with vector and template inference. Hopefully you know it already, but in case you don't, here it goes. Problem F, well, normalish geometry problem. Again, they are not being too crazy about constraints. They just give you several logs, like easy, take whatever you want. But yeah, this sliding window thing, like you sort by X, then you slide window by X, and you need some info about prefixes and suffixes of Y. This is just a common pattern in computational geometry. If you are at the level when you see such problems, you will probably not solve the first one or two of them, but then you will get used to it, and it just comes naturally to me right now. It's the only way that it's the only thing that you could do in this problem. Well, this is not necessary. You can do sliding window to get off n log n and not off n log squared n, but luckily they allow it, so who cares? Problem G, just difficult, probably orange. Combinatorics / probabilities here. Just like the main idea is linearity of expectation. That's the first idea. It gets you to O of n squared. Second idea, you have to know, like, because in the worst case, if you just loop over this array A, it can have linear size. The second idea, which is common, not that common to be fair, but I've seen it several times already this year, is that if you only care about frequencies, then you may, like, there are not too many different frequencies in a frequency array of size n. You can have only a square root of the n different frequencies, so you may as well combine them, because the linearity of expectation again lets you factor out the count of colors, each of which has m elements. Then you figure out this formula and you say, okay, that is already O of n log of n square roots of n log n. However, you realize that your binomial coefficients can't fit in memory, and they take a quadratic time to compute. But then luckily you realize that n minus m can't take too many values because m can't take too many values. So you can compute only binomial coefficients which you want, which is a normalish for loop with like multiply, divide. Then you realize that, okay, actually multiplying and dividing is slow. So you get like a log overheads, which may be not great when you have an O of n square root of n log n solution, which is considered a bad meta, which is why we had a TLE here. But then luckily you again realize that you take modular inverses, but you only take them from a limited set of numbers from 0 to n. So you just pre-compute those ones. So this part takes off n log. Actually, log is not of n, but log of mod, which is like 30 versus 20. Maybe it counts as well. And also n is like not 10 to the fourth, but 5 times 10 to the fourth. It all adds up to TLE, your solution. So instead, you pre-compute modular inverses for only n numbers. So you have like of n log mod here, which is more or less of n log n, and you have of n square root of m here, because you loop over square root of values, and your loop takes of n time on average, and you have of n square root of n time here. Really enjoyed this problem. Great combinatorics, really great computational combinatorics. Unfortunately, we could not take a look at problem H. Maybe we should, but like, hey, keep in mind that only 16 people out of 8,000 could solve it, so I will consider getting a mere 151st rank a success. So yeah. I should probably add more. Oh, and now I remember why I don't add Ukrainians into favorites, because I can just filter by flag, right? So yeah, you can see that, well, it's a well-balanced contest, let's be fair. We have people with pretty much each solve count here that exists. And it's also like clearly partitioned, so like yellow guys and above D1 gets into dans, like they are duns, right? First done and second done. They get into their own group, then like people bluish, cyanish, they get into their group, and then just people go. More people. A lot of Ukrainians participating in AtCoder recently. Interesting. Yeah, very interesting contest. Not the hardest one, but good practice. So, I guess with that in mind, like, I hope that the explanations that I kind of did at the end were sufficient, more or less, if you already had time to think about problems. In case you did not, I can't, like, you probably did it while watching the video. So hopefully they made sense to you. And I'll see you tomorrow. I originally planned to do AtCoder today in the evening, but not so sure because this is exhaustive a little bit. To think for like 2 hours straight, it's complicated, I'm telling you. So maybe I'll see you tomorrow with like our either a problem video or maybe there will be another contest, we'll see. But for today, it's bye-bye from me. Have a great day, and I'll see you soon.